the equations alike and different? Who wants to tell me some way that the equations are alike? Anybody? Okay. They both have an x. What else? What else? Evan?
X multiplied by a number.
Okay, and what is that number like? What's that called? And when it looks like this, what if I took out, you getting there?
Yeah.
What is it?
Slope.
There we go. So tell me about the slope of both of these. If I was to graph it, I'm trying to pull this stuff out from last year. What would they look like?
Linear.
They would be linear. What else? Are they positive or negative? They're positive, and so the slope would look like what? Look down here. Some of these are positive, some of those are negative. Which ones are positive? The ones that are going up. Okay, so that would be the first two, correct?
How do you know if they're going up?
Because we read from left to right. And as we're reading from left to right, this is going up, this is going up, this is going down. Remember that from last year? So this would have a negative slope, but these would be positive. Okay?
Why would they have two arrows on both sides though?
It doesn't matter. It's keeping on going. And if you were to remember how to find slope, let's review that. How do we find slope on a graph? Rise over run. That's right. So you pick a point. I'll pick this one and this one. My rise is how much? Up 5. Up 5 would be positive or negative? Positive. Okay. My run would be to the right 3. Is to the right positive or negative? Positive. So then that would be 5 over 3. Positive over positive is positive, correct? Okay, let's do this one. Pick a point, pick another point. I can go either way. I can go, my rise went up 1, so what would that be? +1, and then my run went what? Left 3, so that would be -3, so then that would be 1 over -3, which created a negative slope, okay? But when we say this arrow on the other end, it just means it's going to keep going. But if you look at it, and again, we're reading from left to right, it's going down, it's sliding down, versus these guys are running up, okay? There's one more thing that's the same and different. Look at the graphs and the equation. One more thing we need to point out. They're all linear.
Each line passes through 2 quarters.
Say it again.
Each line passes through 2 quarters.
You mean quadrants? Yeah.
No.
What else? There's something I'm looking for. Nobody's saying it yet.
The first two pass through the origin.
That's what I was looking for. This one and this one go through the origin. What about this one up here? Which one of those would go through the origin? The first one. How do you know?
No +4
Because it would be +0, okay? And then here, it's not going through the origin. What's that called? The y-intercept. What letter is it? B. Is it all kind of coming back from last year? This is not new information. Where do I see it on that equation?
+4.
The +4 tells me it's going to be starting up there at 4, okay? Okay, hopefully the more we do this, you're going to be like, oh yeah, I remember all that. Okay. So today, you have your notes. Today we're talking about direct variation. Direct variation is going to use something that we already know, but maybe we didn't call it that last year. Okay? Direct variation is another way of describing a relationship between x and y that is proportional. So there's that word again. We've used the word proportional several times over the year. What does it mean?
The same amount of what?
Kind of relative. I like that word. When I talk about proportional, I usually use an example of, and I can't remember if I have it in this class or not, like with making Kool-Aid.
Oh, yes, yes.
right?
Yes.
Like if you ever make Kool-Aid, it's usually like 1 scoop of Kool-Aid mix to like a pitcher of water, right? But if I want to make 5 pitchers of water, then I need 5 scoops. If I only put the same 1 scoop in for the 5 pitchers of water, what happens? It's going to be really watered down. Or if I put 5 scoops in for 1 pitcher of water, it's going to be like so sweet and right. The proportion is off. It's not proportional. Okay. So direct variation is when we have relationships that are proportional. In direct variation, one variable will always be a constant multiple of the other. Okay, that's kind of what I just said with the Kool-Aid, right? Okay, constant of proportionality. Now, this is something that we learned last year. Give me a thumbs up if you actually remember what it is. Okay, only a few. Okay, at least you're honest. I appreciate you. Situations that vary directly can always be represented with this equation, y equals, all right, kx. K is the constant of proportionality, or the ratio of y to x, okay? So y equals kx, let's go back to the warm-up. Y equals kx. Well, which ones look like that?
I know the first one.
This one looks like that. And then which graphs?
The first two.
The first two, because they're not going to have this. They're not going to have a number. It's going to be plus 0. Okay. To solve for k, you're going to divide the y value by the x value. Okay. Since somebody mentioned slope in the warm-up, is it the same as slope? So let's go back for a second. You told me, I erased it, but you guys told me to find slope, I do rise over run. Those are like layman's terms. Those are like, I'm just saying how to do it. What this actually means, though, is the change in y over the change in x. This is just what? Y over x. Is it the change in y over the change in x? No. Now, do you think sometimes they could be the same? Whatever that is, please put it away. Do you think sometimes they could be the same? Yes. And last year, as you guys might remember, we had this whole day of KAP versus Croc. Y'all remember that day?
Oh, yeah.
Well,
My whole class wore Crocs that day.
we did. It was this whole day when Croc is constant rate of change, otherwise known as slope, and KAP is constant proportionality. And so we had this whole day where we compared them, and you guys came to a conclusion at the end, but I'm not surprised that some of us forgot. It'll probably come back as we, like I said, the rest of this week, we're touching it again, okay? Okay, in each of the problems below, assume that y varies directly with x. Okay, so they're telling you y varies directly with x. That means y over x. To find the value of k, and then write an equation to describe the direct variation. So k would be equal to y over x, which would be 6 over 9. I'm just plugging in the numbers that they have. 6 over 9 is equivalent to 2/3. So if k is 2/3, then what would the equation be? Y equals 2/3 x. All of the equations must have a y and an x, correct? Okay. All right, let's do this one over here. So k equals y over x, 18 over -3. Well, what's 18 divided by -3? -6. So now what would your equation be? Y equals -6x. Am I going too fast? No. Okay. Let's come down here and do one with a fraction. Those look fun. Y equals, I'm sorry, k equals y over x. So y is 4/5. x is 4.
Oh, no.
And last year we said, oh no. But this year
I still say, oh, no.
we have our friend, Mr. Calculator. So why would I say, oh no?
We still say, oh, no.
You shouldn't. You have a calculator.
I know,
I'm just
Oh,
used
here.
to, I'm just used to saying, oh, no.
Okay.
yeah, because
What do you get?
everything
1/5. If you did not get 1/5, please let us know.
Yeah, that's our really real fraction. That's our really real fraction.
Let's remember how to do this in case you didn't want to do it with your calculator. Remember that this means 4/5 divided by 4 over what? When I divide fractions, I multiply by the reciprocal, which is why those go away and I ended up with only 1/5, okay? Remember that? Okay. All right, one more. One more. Oh, I'm sorry, we forgot our equation. Y equals 1/5 x. Okay, one more. What y'all get for K? Ooh. What y'all get for K?
36.
Wait, 36.
Ah, what's the difference between them? What do you have to do? You need parentheses around that fraction. Okay? Because it's going to do order of operations, but we want, it's 24 divided by parentheses 2/3, which would be 36. Because think about what that means. That means you're taking 24 whole things and cutting them into 2/3 sections. So how many 2/3 sections would there be? There has to be more than what you started with.
And then we're just dividing by 2 and then dividing by
Right.
3.
Okay, so then our equation would be y equals 36x. Okay, guys, there's just 2 left. Go ahead and try those on your own and then we'll check. Okay, for the first one, I got y equals 7.5x. Did y'all get that?
Yeah.
And then on number 4, y equals 28x. Okay, what do we notice about every single one of these? What do y'all notice about every single equation in general? And I want you to write this at the bottom. Every equation what do you guys notice? What is the same? There's one thing that is the same about all of them.
There's no way.
It's linear.
Say it again.
There's no way.
Well, almost.
Y-intercept is
It's
0.
zero.
The y-intercept would have to be 0 because they all look like y equals kx or y equals mx, if that makes you feel better. Because what's the parent equation? Y equals mx plus b. That's where we started reviewing from last year, right? Well, so then, could you say m stands for what again? Slope or something else? There you go, which means
Constant rate of
constant rate of change, right? And K stands for what? No, it's on your notes. Get out of this.
Constant
Thank you. I don't know why I can't get out of this, y'all. Oh. I was like, oh, there. It was up here, right? Constant proportionality. So when are these the same? So K is M.
equals M when.
When what?
the y-intercept is 0.
There you go. When B equals 0. So tell me about times when B equals 0. Multiplicative equations. What else? When there is the title of our lesson today,
Direct
direct variation. Okay. Really? I can't. I'm gonna do better. Yeah. Okay. Okay, maybe the next page is. Miss Baylor's ahead of me apparently. We'll see. Oh, I have something different. No, it's not. Okay, that's right. All right. Now let's get to the next one. So we just did, if I give you Y, if I give you X, correct? So now we have a table, all right? An amplifier generates sound with an intensity that changes with the power input of a constant ratio. The table shows the relationship between the input signal power in watts and the resulting sound intensity in watts per square meter. Okay, so our input, they put W, but I don't think in terms of like W's. I think in terms of what? X and Y. So input is going to be what? X, and output is our Y. I would just put that over there, even though I know they want me to put some W's, okay? Okay. All right. So first we need the ratio of output sound intensity, or Y, to input sound intensity to X. Okay. So let's do that. So that would be 1.5 to 2, 3.75 to 5, 9 to 12, and 14.25 to 19. Guys, can I only check one and be done with life? No, I have to check them all, because if I'm looking for a constant, of course, proportionality, then I need to make sure that it's constant the whole time. So now that we have our handy dandies that we didn't have last year, let's go ahead and just type them all in. First, were they all the same? Yes, what were they?
0.75.
0.75. Okay, so since the ratios are proportional, the data set shows direct variation. The constant of variation would be 0.75. That's also K. Okay, so we're going to write our equation. Let X equal the input power. Y is the what? Sound intensity. So then what is K? 0.75. Okay. And if it asked you to write an equation, it would be Y equals what? 0.75x. You're just taking that K and plugging it into the spot where it goes. That's all. Okay? I know. Okay. So now on the bottom, just making sure y'all match. Okay, on the bottom, go ahead and try those. It says to tell whether the table is a direct variation or not, and if so, write a direct variation equation that matches the table. What if there's not? If it's not direct variation, can you write the equation right now? No, so you wouldn't do that. Okay, so go ahead and pause. Hello? What did y'all get for K over here?
Y equals 5x.
1/5, right? So therefore the equation would be Y equals 1/5 X. Also, some people want to turn that into a decimal. If you'll think back to last year, remember what that actually means. It means rise over run, so we want to leave it as a fraction because that's going to tell us what to do in our graphs. You should be able to picture it's going up 1 and going to the right 5, up 1 over 5. So it's going to go up, but it's kind of flat, right? It's not very steep. Okay. What about this one? There was not a direct variation here because -8 over -2 is 4, but 32 over -8 is -4, so there is no direct variation. There is no K, therefore I cannot write it as an equation at this time. Is everybody good so far? Okay, so now apparently you guys don't have this in your notes, so just take a look. It's okay because this is like super easy. So we talked about it already. If I give you points, X and Y, you know how to do it. You did it from the table. Now let's look on a graph. It's the easiest one. To know if there's direct variation, first you ask, is it a straight line?
Yes.
Yes. Okay. Does it pass through the origin?
Yes.
Yes. If it's yes to both of these, then you can find K and then plug it in for an equation. Okay. So like, for example, here's a point. That would be the point 230. So that would be what? I'm sorry, 15. 15. So then K would be 15 over 2, which is 7.5, or we could leave it like this. So Y equals 7.5x or 15 over 2x. And it's just that easy. Okay, let's go back to the warm-up since y'all don't have this in your notes. Okay. All right, which of these would have direct variation? The first one. What about this one? The second one. And what about this one? And what's wrong with it? It doesn't go through the origin. And then think about some of those things from last week that were functions. What about like that? No. What about like that? No, it doesn't pass the vertical line test. It can't be a function. Okay. All right. Yes. Okay. So what I was looking for that I couldn't find is the word problem. So guys, we're just going to have to improvise. Okay. Y'all have it in front of you and we'll just talk through it. Okay. It says a local fast food restaurant takes in $9,000 in a 4-hour period. Seems like a lot, but I don't know. I don't run a restaurant. Write a direct variation equation for the relationship between income and the number of hours. So income would go on top, number of hours. How do I know that? How did I know where to put what?
Because it's direct variation equation relationship between the income comes first and the number of hours.
Yes, that's one way because it actually told it to me between this, and it's always y to x. But also, let's think back to independent versus dependent variables. Which one is independent? Then the x value, which is the number of hours. It's the income that depends on the number of hours. Is everybody with me? Okay. Then it says to write an equation, estimate how many hours it would take the restaurant to earn $20,250. Okay, so first, let's do y over x. So this would be 9,000 over what? 4. Did everybody get that?
That's it, guys.
Okay. Okay, and what does that actually mean? Dollars, what? Per hour. That's important for you to understand the context here because the next part says first to write an equation. So that would be y equals 2250x. Okay. B says estimate how many hours it would take the restaurant to earn 20,250. Well, I'm looking for 20,250. So I need to replace one of my variables. Which variable am I going to replace? Why? How do you know? Because what is 20,250? Is that income or is that hours?
That is income.
That's income. So I'm going to replace here. So 20,250 equals 2250x. Now what do I do? How do I solve this equation? You just divide, right? Y'all are looking at me like you don't know how to solve this equation. Just because there's big numbers, don't let it bother you. And what do you get? 9 hours. Okay? If you divide it out, it was 20250, not 22250. Okay, all right, you guys try number 11. Try number 11 and then we'll check. So it says that the distance from the lightning varies directly as the time it takes you to hear the thunder. So I wrote that down. Distance from lightning over time to hear thunder. This is my Y, this is my X. So 2 miles for every 10 seconds. So A says to write a direct variation equation. So K would be 2/10, which is equivalent to 1/5. Y equals 1/5. And B says estimate how many seconds it would take for the thunder to travel a distance of 4 miles. So what does that mean? In this equation, Y equals 1/5 X. Miles are my what? Hello? Miles are my what? Y. So that means I'm going to replace Y with 4, right? 4 equals 1/5 X. Now what? How do I solve that? Yeah, divide by 1/5, divide by 1/5. I haven't worked it. So 4 divided by, don't forget your parentheses, 1/5. And what'd you get? How much? I get 20. 20 seconds. Let's see if that makes sense. Thinking about this a different way, about a 6th grade way, right? I was trying to change my phone. If I wanted to get to here, how could I do that? Times 2, and then 10 times 2 would be 20, right? So that was just a way for us to check and make sure we got it right. Okay? Okay. I have a GIMP kit for us, and we do have time to do it. And then I also have a homework page, which I have not given you yet. Okay? So go ahead and grab a device for GIMP.